English and Japanese expressions. Okay, and I'm telling you background and the purpose of this research. The first, okay. The starting point of this research is my interest toward the Japanese phrase "black企業." Black企業is the Japanese phrase, and it is literally translated into black company in English. And can you imagine the meaning? Actually, even for Japanese, it is not easy to define the phrase "black企業." But however, we can handle the phrase in daily life without any troubles. So I assume that Japanese have a common image toward the color black, and the image toward the black is maybe common with the image of English speakers. And moreover, the research interest has been extended to the opposite color tone, I mean the white. So I'll show you some previous researches. First, variant K showed that the 98 different languages contain color terms for black and white. So it means that these two colors is the most basic and essential for human beings in many linguistic areas. And so I think conducting the research is meaningful and can attract people in the world. And one more previous research is the Japanese one, and Takei showed that the image toward black and white are similar all times and all places. So black had bad images and white has good images. But why does the common sense exist? I'd like to claim that the reason need to be revealed. So first, I'd like to share my research approach. It's cognitive linguistics. There are some of the basic ideas of the cognitive linguistics, and our consular means like a perception of outer world is unconsciously reflected on verbal expressions. We have concepts, it means image, we have images for each thing, and the concepts are formed through our daily lives, our daily experiences. So by analyzing verbal expressions, it can be revealed that what kind of concepts do we have toward black and white. So let's move on to the contents. Begin with the concepts of black and white. First of all, every word must have started with the only one meaning as it emerged, and then people has developed their meanings one by one. So it means that the process of extending and expanding the meanings reflect our way of thinking. Therefore, I can reveal the logical connection between the meanings. So original meanings of kuro, kuro is a Japanese word, black, and shiro and white. Shiro is a Japanese word too. Must be the first point, must be the starting point of my research. Then I'm telling you the origins of Japanese word kuro and black. Japan Color Research Institute said that the origin of kuro is kurashi. It's a Japanese phrase. Kurashi means darkness. Okay, so the origin of the kuro, the Japanese color term for black, is darkness. And on the other hand, in English, what Patrick said that the original meaning of English word black was burnt. So also Terasawa shows that the process of extending the meaning, like burnt to ink to black as color terms. So you see the Japanese word kuro has a concept of darkness as its origin, but the English word black doesn't. However, it can be proved that English speakers have the same concepts of darkness toward the color term black. Please look at the examples. The room is black as night. It was a black and moonless night. And each black in this sentence can be replaced by dark. The room is dark, or the room is dark as night, or something. So this, and of course, without changing the general meaning, right? So I concluded that black and kuro have a concept of darkness, and I claim that the darkness leads to the negative images, as the previous research said. But why? It has something to do with the perceptual system of human beings. Suzuki said that among five senses, the most important one is sight. If their eyes do not work, they generally cannot perceive almost all of the outer world. So the concept darkness of black has been extended to the concept invisibleness. And whichever cultures they have, the condition that people cannot perceive with sight is an essential matter for human beings, right? This argument is also supported by verbal expressions in both English and Japanese. This one is an English example. Terasawa said the original meaning of English word timid. And timid originally meant be in the dark. So this means that to be in the dark means negative feelings like nervous, shy, not confident, or easily frightened. Then I give you a Japanese expression as an example. It's a Japanese phrase, yami yo no tomoshibi, and it can be literally translated a torch in the dark of night. And it has a metaphorical meaning, the most useful thing when in trouble. So this means that darkness is a symbol of something to be avoided, and therefore, Berg has come to have the concept of badness from invisibleness. All right, then I'll show you again the concept of Japanese kuro and English black. The origin of kuro is darkness, and the concept darkness extends to two kinds of invisible, and the negative one is the image of badness. On the other hand, the origin of black is burnt, and then the concept expands like this in the color tone and darkness. And then, same as kuro, black has come to have the concepts of two invisibleness and badness. Right. Next, move on to the color white. Shiro is a Japanese color term for white. So according to Kamata and Yoneyama, shiro originally meant rose thread just laid off from cocoon. The color of the rose thread is white, so shiro has been used as a color term. In addition, shiro has come to have a concept nothing, because nothing is added to rose thread. And the nothing has been extended to transparency, like white glass, or in Japanese, shiro garas or something, right? And then move on to the English word white. White partially has a conceptual parallelism with Japanese word shiro. First, Ueno, Terasawa, and Pepperidge said that the original meaning of white is sunshine. And sunshine has been extended to transparency because the sunshine breaks the darkness and brings us outside back. So for both Japanese and English speakers, sunshines give the advantage of the sight. So white has a concept of goodness, just like opposite the darkness of the black, right? So then I wrap up the explanation of concepts of shiro and white below. The origin of shiro is rose red, and it expands the meaning like nothing, transparency, sunshine, and goodness. On the other hand, the origin of white is sunshine, and the sunshine expands its concept to goodness and transparency. Okay, its conclusion. So lastly, prince on the white horse is a symbol of a hero, right? And white doves are the symbol of peace. On the other hand, a black cat or a black crow is a symbol of unhappiness or unlucky. So with evidence based on verbal expressions, this research has proved that English and Japanese speakers have similar concepts toward the color black and white. And I will pursue the connection between the mind and the verbal expressions concerning the color terms in further research. Okay, there are some references, and the lastly, there are much more examples of verbal expressions. The paper, written paper, I hope lately published. Right? Thank you very much. That's all.
So, good afternoon to everyone present here. I'm Ananya Katali. I'm currently in my final year, pursuing my master's in mechanical engineering with specialization in robotics CAD and CAM. And today I'll be presenting my paper titled Quadruped Robot for Landmine Detection and Network-Based Location Sharing. These are the points I'll be covering today. So basically, over the years, warfare has evolved from human physical combat to using advanced machinery. And now, with the help of drones or biowarfare, the attacking party need not be on the field to attack a particular place. And a more localized and effective method, which the opposite party uses, is the use of landmines, which affect not only the flora and fauna but also innocent human lives of people living in that area. Now, UN Mine Action Services describes that there are about 100 million active mines which are there in about 78 countries, and the effects of these landmine detonations, as seen in the graph, is like the maximum casualty is to civilians. Then it goes into the military operating in that area, and lastly, the deminers. So um, basically, using human operators, the human deminers, yes, they work on their expertise to demine those particular machinery. However, if we introduce robots with using the same landmine detection sensors or their setup and train those robots, to some extent, these landmines can be detected and demined, which can help save the human life, as cost of replacing these robots is much more better than loss of human life. Now, quadruped robots like Spot by Boston Dynamics is like well known all over the world for whatever use cases they are working in. These robots, like Comet One, are also used for rescue missions, and India has got its own Daksh rover that is for explosive device identification. So mine location is one thing, and demining is basically a next level of expertise. And as I mentioned before, if they can be trained using various sensors like the ground penetrating radar, holographic radar, they are much more expensive but much more effective. Now, since my project was a bit on the prototyping, I have used low cost but still slightly effective sensors for developing my robot. So the before going into the project, obviously a bit of research was done for the background. So it was split in two parts. One was to understand robot development and the gate or the locomotive that should be used. And second was about mine location, demining, so what sensors, the path planning, how to relay the data, and so on. So maybe certain gaps that I found or what I felt I could work upon was a lot of wheeled robots. There's a lot of importance given to wheeled robots. So the use of legged robots in the field. Second, to come up with a simple and low cost circuitry and setup that can be worked upon or can be done easily in that particular place or by someone. And last, how to collect the data and transmit it when, especially if you're in a remote location, how that would work if you have network and no network connectivity. So the objective, as I mentioned, use of legged over wheeled. Why? In an undulated terrain, it is way better to use a legged robot, as there is stability, less consumption. You can maneuver it on that particular terrain, and it's easy for obstacle clearance. Also, as I mentioned, using different ways for data transmission or for location. So using RFID, something as simple as that, instead of going into something too high tech. And lastly, available sensors and exoskeleton materials to make the robot in such remote locations. You can't 3D print it or outsource the materials at that particular time. So basically, the aim was to develop a quadruped robot with affordable items, detect the landmines, and relay the location when you have internet, no internet connection. So that is GPS or an RFID system. So the progress went in from doing a literature review, then it went into making the robot, then it went into coding for the robot and its locomotion, introducing the sensors, about how to send the data, and then obviously a future scope would be there too. So the simulation was done in MATLAB Simscape. It is like a subsidiary of MATLAB, wherein your physical systems can be simulated. You can import your model from CAD/CAM software, or you can make it completely in the Simscape environment. They have blocks for it, and it works very similar to Simulink too, because you are simulating that particular environment. So why quadruped robot? Why not a hexapod or something like that? Quadruped is the most simple to start with. You're using a 2DOF leg limb in that, so it's easy to work, at least for the starting as to understanding how to develop the robot. It's easy to dynamically balance and maneuver the robot for the particular algorithms I would be using. So this is static robotics. So there is no feedback in terms of PID control or force sensors and anything. So basically just using the inverse kinematic equations to find the motor angles with the help of theta 1 and theta 2. And the prerequisites would be the desired height of the robot. So the next slide, the desired height of the robot means from its body to the ground at every point. Next would be the link length. So that's L1 and L2, and you have to calculate the angle theta 1 2 through inverse kinematics. Step size is x, means how much distance the leg should move ahead for the forward movement of the rope. So the gate implementations, there are different gates which robots usually use. So you have creep, trot, which are the most well-known ones. Creep gate basically works on the fact that for every time the robot's leg moves or its movement, the center of gravity should always remain between the figure made by the other legs which are touching the ground. So if one of the legs is in the air, the other three are on the ground, the center of gravity of the body should remain within that triangle, or if all four are on the ground, it should remain in that quadrangle. So this is achieved by either shifting the body front or behind to maintain the weight and center of gravity at each point. Trot gait is when you move two legs at a time and other two on the ground, but that's a bit tricky because it's split second movements and it can topple because of weight distribution. So basically the four positions of the leg for its movement would be alignment, which is this blue one. When it moves ahead a step size, this is the next blue. When the body moves ahead to alignment position is this orange. And when you have to move the body ahead or behind to maintain the center of gravity, this is the fourth position. The side step is basically if it sees an obstacle or metal, it has to move to the side. So I have used the same concept of creep, but for side step movement. So in the diagram, like this leg moves, then the back leg, then the body shifts, then another leg, then the other leg, and the body shifts, and this process continues ahead. So these are the angles when I was calibrating, because motors have got some certain error in them, and these are very easily available motors, so they have the error. So I had to calibrate each time I used it. But if you do it via inverse kinematics and or geometric method, the angle remains the same. So when you code it in the diagram, you just in your code you just put the error and you should get the same values. Now, working logic is basically if there, for since I said it's stable, there is no feedback. So there are four conditions for the movement. If there's no obstacle, no metal, it will move ahead. But if an obstacle or metal is detected, it will move to the side. Now, if it detects a metal, then the network-based location sharing comes into the picture, where it is either through GPS or through an RFID tagging system. So basically, if it detects, here I am detecting metal mine. So if a metal or a mine is detected, it checks if network is available. What I mean by that is GPS doesn't really require any network as such. It just needs, like this module needs at least three satellites to send the latitude and longitude. But if you want to send it to the base, you can do it over um, Wi-Fi, this thing, or through radio also, which is pretty high level and high intense. But if you send it and put it into, say, a Google Sheets or Excel, and if you use a scatter line plot, a basic trajectory of where these mines are located will be, you will get a pictorial representation of that. Also, even if there is no, if the GPS is still collecting data and if there is no network, it can store all the latitude and longitude data into an SD card, which is also there. Now, if there is no connection, GPS is just failed connecting, then you can have a physical motorized ramp or a separate arm that will place RFID tags. So once after a particular distance, say the GPS doesn't work or something, the D miners can come with RFID locators and they can find out, okay, in these places the mine was located. So in both the cases, the robot moves to the side. And throughout this entire process, I have used an ESP32 cam for video streaming the entire. So this was basically the robot that I made. These are the components that were used, and the robot hardware was with using aluminum sheets and fiber pieces. As I mentioned, it was to be with readily available materials. But to handle the weight of this robot, maybe better composite materials that are light but can hold this weight would be better than using fiber pieces. So these are pictorially about all the components used. So the servo driver was to control the 12 motors, the SD card module, tagging, metal detector, the GPS, ESP32, Arduino sensor, and they all work on 5 volt 2 amps. So I was for prototype, I was working with the your normal power connection from the wall, so with the mobile charger, but you can use rechargeable battery too. It will make it much more better and autonomous also. So the walking video, if you paste this drive link, you'll be able to see basically what I meant as the creep gate, which is there. This is the quadruped simulation in Simscape. I have made the framework of the robot here. If you run it, you will be able to see like this is how it will show a simulation. This is the video streaming that will happen the entire time. Here, this is the metal detector. So every time it detects a metal, the LED will light up, and then one of the four conditions in an if-else code is there in the Arduino program. Then you have the latitude, longitude. You can code for this altitude, time, whichever parts you want in it. And this is dummy values just to show the scatter plot of, if you put the latitude, longitude, where each of these mines are located. So it will give you a basic idea as to where it is on the field. So obviously, the project has gone through different stages development. So it started basically with nothing but simulation. Then slowly it got into the development of hardware, then coding, then putting sensors and all. So right now I'm in a phase where I can kind of work on the future scope of my project. So concluding was basically to understand how to implement what I learned in my syllabus also in real life in developing a robot. Second, understanding about robotics and its concepts. Third was to, as I mentioned, to use readily available materials, keeping it low cost, but being effective enough to find out at least metals or these metal mines in the place. And it is basically to understand that in these kind of remote locations where it may take time for the military or for the deminers to come, at least this will save time by finding out the locations and making it much more faster and effective. Obviously, future scope enhancements would be introducing dynamics, that is where you have PID control, force, you can force sensors, you have gyroscope, you introduce SLAM, you put IoT, you scan 360 degrees, because right now this project is only for walking forward, but if it sidesteps and goes onto a mine, then that doesn't work good. So obviously to scan 360 degrees and to use better materials to develop the. So these are the few of the many references, and also in the literature survey that they were there for which I referred for my project. Hope it was informative, and thank you for your time.
As a background, I'm a research scholar with Himalayan Garhwal University based out of India. I'm doing this under the guidance of Dr. Purnima and Dr. Indrapal. Uh, this presentation is part of three presentations I have lined up for today. This is first of the series, and this presentation will primarily deep dive into my subject area, which is data architecture. Uh, the research I'm doing is primarily to understand how we can enable the current data architectures for extreme data processing. This paper will presently talk about what are the options available in the existing data architectures in the market, and that is what it will talk about. Is not a detailed one, as I said. It is first of the series, so this is the agenda lined up for this particular presentation. Uh, from a context perspective, as I said, my area of interest is data architecture. As we all know, over the past few years, the volume of data has grown multifold with use of internet. While we are talking about the volume of data, there is profound increase in the variety of data as well, whereby in past we were interested in structured data. In the recent times, we are also interested in semi-structured and unstructured data. So while I talk about structured data sets, we were more talking about tabular data, which we were familiar in the past, where you were able to store your data in row and column format. But in the recent past, you might have seen that you are able to manipulate your video, audio files. You talk about semi-structured data, where part of data is available in certain piece and format, and rest of the data is not available in similar format. So the research is all about how to use or extend the existing data architectures to leverage existing capabilities and the capabilities which will be available in the market in near future to take care of extreme compute capabilities. Now, I have taken references from multiple places, starting from some of the patents filed by Lascelles, Forrester, and Dan. There were people like Owen who have written something about limitations of data architecture, taken references from there where the current architectures are limited around certain scope areas which are depicted in this slide. Primarily, the data architecture in today's work talk about these fundamental principles, which starts with acquiring the data, which is shown here as data acquisition. We are interested in storing the data for our analysis or business context to see how well or how bad we are doing. We manipulate the data so that we can transform the data in a way where we can present that into a business KPI, which should reflect how the business is doing as far as day to day transactions are concerned. And then a consumption layer, which primarily focuses on uh, how, which format and when the data should be consumed. For example, someone may be interested in looking at a executive level dashboard to see how my sales or product growth is. On the other hand, a lower level analyst may be interested to see how my each transaction or each customer is doing. Then other aspect of data architecture talks about securing the data assets available in the organization. And overall, while we talk about each and every data architecture aspect, governing the data through management and data governance processes is of prudent importance. Having said that, um, as I laid down the importance of data in the earlier slide, some of the benefits which organizations are reaping today is to derive better insights for the organization, leveraging the operational as well as historical data. uh, with better use of data, they can better manage their data supply chain. When I talk about data supply chain, it is primarily the process of acquiring the data till dispersal of the data. And this consists of multiple steps, starting from data acquisition from third party applications, from end consumers, or from a POS system, uh, then kind of transforming or curating the data where the data is transformed into a usable format for the organization, and then it is being consumed by third party application, regulatories, or for that matter executives. uh, Similarly, uh, if the data is of not good quality, it makes no sense to me, because I will not be able to derive right insights, or even if I will be able to derive any insights, they will not land me to right conclusions as far as my day-to-day decisions are concerned. So data architecture is very important for any and every organization, given majority of the organizations are moving towards a data driven organization today, where they are leveraging full benefit of data to derive their business decisions and their product decisions. If I talk about some of the common frameworks available in the market around data, uh, TOGAF is open source and most widely accepted. It is based on four key principles, or pillars, as to say. These four principles are business architecture, data architecture, technical architecture, and application architecture. While my focus is on data architecture, it is important to understand that even for all three pillars, whether it is business, technical, or application architecture, to derive the right architecture vision, this is enabled through data architecture only. The linkage between all these architectural principles is data and the underlying data principles. Now, whatever data architectures are available in the market, uh, how are it being influenced? What are my key themes before I decide my target state or data architecture for an organization? So some of them are listed here based on my research, which is based on action and exploratory data analysis um, directly in the industry. Uh, One and utmost importance is given to the architecture vision, and this we can relate with strategy, right? What is my business strategy or data strategy for the organization? What is my short term, mid term to long term vision as far as my architectural decisions are concerned? This is further tied back to technical architecture, because end of the day, whatever my architecture vision is, it is bound by the technical architecture, the tools, the network, and the applications which will be consuming this data. So that is the reason why technical architecture is of utmost importance. Then another important aspect is how do I want to use this data in the enterprise? Some of the common terminologies which we hear in the industry is OLTP, which is transactional processing data sets, which are primarily your point of sale systems through which you derive your operational reports, or maybe analytical processing systems through which you derive historical data trends to see how well or how bad the organization has gone based on the strategy laid down. Uh, Other aspects which can impact my data architecture are the volume of data, what is my driving factor for the data architecture, and last but not the least, what is my long term to short term strategy. Uh, Now, if I need to talk about some of the common challenges what organizations are facing today as far as data architectures are concerned, and this kind of uh, one of the motivation I have to look into this field is primarily, even if I look at various architectural principles available in the market, including big data architectures, the data is still sitting in silos in different business units, in different organizational divisions, even in smaller pieces and bits. So that is one of the hindrances you have as far as data architecture is concerned, and we need to break those silos if you need to reap benefits from your data architecture. Second biggest challenge which we are facing is that while we capture the data, everybody feed data based on their understanding of the system, based on their flexibility and ease, and at times we need to cleanse this data. As I earlier pointed, the volume of data has grown multifold in the recent past. Cleansing this data and preparing it for consumption before we take any final business outcomes from this is a very tedious and time consuming process. Uh, at times, we had seen that organizations are not ready. They start their data journey even before they draft their data strategy. That is another big challenge, because if you try to draw some conclusions on your architecture before thinking about what should you be doing in near term versus long term, you will land nowhere. On top of that, data governance is important. Data governance looks at multiple aspects, starting from the people who will be consuming this data internally and externally, including regulatory or compliance requirements, the processes which should be needed in order to manage your data assets in the organization, so that you should adhere to internal and external requirements. And third and foremost thing is the technology which will help me to enable implementation of the data architecture. Now all these three are required to draw business value for the organization, otherwise this is of no use. End of the day, we are doing everything for return on our investments as and when we are implementing any data architecture. So we also need to think through the total cost of ownership before we start implementing any data architecture. uh, the vision, the peer pressure at times has been seen one of the challenges people or the organizations are facing in the market today. For example, I can recall one of the examples where one of the largest US retailer started their analytical led data journey, because one of their competitor in the market has already started that 2 years back. Even they were not ready for that. So that is also one of the factor which influences data architectures. And last but not the least, the time to market and the talent available within the organization are also prudent while we implement data architectures, and these are the challenges which everybody is facing. Now, while this sets my foundation for my research in this area, where we are growing as far as data architecture is concerned. So we had recently seen that majority of the data architectures are moving towards an automation phase, where we are trying to do um, management of data through data ops, or maybe DevOps, or maybe machine learning operations, etc., which are now easily available in the market, which took years to implement in the past. We had seen databases likes of Snowflake, Databricks, which are self-healing and self-managing. Uh, we are seeing growth in AI market, where Gen AI has came into play, which can help you to code and architect the models. Large scale computing is not a dream anymore. Data driven or analytical driven businesses are now a reality. And uh, System driven governances are now becoming more and more adaptable in the organizations. Having said that, um, in conclusion, I want to say that this is a field which is rapidly growing. uh, this has utmost importance in the recent times, given the importance of data for day to day business decisions, for immediate or long term impact. We need to rethink how we are managing the data assets within the organization, so that we can reap the benefits in a better way. These are some of the references which I have taken to conclude this study. I hope the session was uh, beneficial to each one of you. Thank you.
Hello, everyone. I'm really happy to be here. Just let me put my slides on a better presentation. Okay. So, hi, my name is Rachel Nixon Holt-Ganor, and I'm happy to present this paper about assessing hospital quality measurement programs, a comparison that we did between the programs in Israel and England. And I have no conflict of interest to declare. So, as we all know, quality measurement programs exist in Israel and around the world, many places doing quality measurement programs. And the reason is that through these programs, health systems can monitor and follow after quality indicators in order to improve the quality of medical care. Israel and England has programs, and both of them doing measurement of quality indicators in hospitals. Our objectives were to compare the programs for measuring quality in hospitals in Israel with the corresponding program in England in terms of the process of determining indicators and the ways of collecting data and the ways of reporting and publishing this data. And we also wanted to review the similarities and differences between quality measurement programs in hospitals operating in the two countries, and to examine the performance rate of similar indicators in the two countries. Not all the indicators are similar, but we chose a few indicators that were similar. How did we do it? So we did a comprehensive literature review, which was conducted to learn about the quality measurement programs in hospitals in both countries. And we also designated websites for programs from which more information about the programs was derived. So what did we find? So in our comparisons, we saw that both England and Israel has legal basis to their program. The programs are according to the law. We saw that the English program is older than the Israeli. In England, they started it in 2008. In Israel, they started it in 2013. Who is in charge on this program? So in England, it's the NHS, the National Health Services, with cooperation with NICE. So these institutions are in charge of making the indicators and implementing it to the health systems. In Israel, the Ministry of Health is doing this program. And I also want to indicate that in Israel, there is another quality indicator programs in the community, and the Ministry of Health is not in charge on this one, but on the hospitals program, the Ministry of Health is in charge. The collecting data and analyzing it is the NHS in England, and in Israel, the Ministry of Health. The institutions in both countries give these, the NHS or the Ministry of Health in Israel, all the information about the indicators, and and after that they analyze it. The NHS Digital is also responsible for publishing the data and the comparisons between the indicators between different health organizations. And in Israel, the Ministry of Health is publishing the data. In England, there is no maximum number of measures. And in Israel, there is a maximum number of measures, which is 70. And in England, they don't set goals for the measurement. And in Israel, they do, which means that if you have a measurement, like a health indicator measurement, for example, for the people who are coming with to the ICU are going through several checks in 2 hours. This is kind of goal. So in Israel, they put goals to each measurement or almost to each measurement, but in England, they do not. And the mechanism for extracting measurements, so they have it in England, and they also, of course, have it in Israel. We also looked at the what kind of measurements are in these two countries. So there are 39 process measurements versus 74 in Israel. Outcome measurements, there are 61 in England and only 5 in Israel. And operational service measurements, there are 61 in England and 1 in Israel. So which means that all in all, there are in England 161 measurements, and in Israel 80, which is twice more. So it's like a lot of data to measure and to analyze. Another thing that we wanted to check is the pay for performance, which means does the physician get paid according to their scores on the measurement? I mean, if you are doing it well, you will get more money. So in England, they get more money, 25% from the salary of the physician are according to their scores in the measurement. And in Israel, they do not. I mean, it doesn't matter if you're doing well on the measurement or not well, you're getting the same amount of money every month. We also took several measurements which were very close, as very similar, and we checked the scores of the measurements. So one of them is the femoral neck fracture surgery within 48 hours. How many people were coming with femoral neck fracture to the hospital getting surgery in 48 hours, which is very important for the quality of life of the patients. So in England, 70.6% of the people with femoral neck fracture are getting surgery within 48 hours, and in Israel, 86%. We also checked another measurement, which is cardiac catheterization rate within 90 minutes of arrival at the hospital in patients with acute myocardial infarction. I mean, if someone with acute myocardial infarction is coming to the hospital, he has to get the catheterization in 90 minutes. Otherwise, it's it's not good. So in England, we see 88.9 people were coming, patients, of course, work percent, like 88.9% of the patients who are coming with this situation are getting it on time. In Israel, 80% and 90%, which is it's very close, very similar. And how many patients get recommendation for aspirin administration in myocardial infection on discharging? When they discharge, they have to get aspirin. And how many of the patients are getting aspirin? In England, 90.5%, and in Israel, 98%. I also wanted to indicate that in both countries, when we look at the measurement across time, we see a trend of better medicine. I mean, we get better treatment. So it's very important. These programs are very important. Anyways, as you can see, the Israeli measurements is a little bit better than the English one. Both are very good, but Israel is a little bit better. So we can say that the results of the identical measurements in Israel is better than in England, even though in England there is a reward for the indicator, in Israel there isn't. And the reason for this is probably that the program in Israel sets targets for the indicators, while England does not, and both countries can learn from each other in order to improve the quality of health services provided in them. And of course, measuring indicators can contribute to the quality of care. Thank you very much for listening and for having me today on this conference.